So if we look at this first one, it says iron 3 chloride and magnesium metal. So the first thing we need to do is we have to come up with what iron 3 chloride looks like. So do you remember the element symbol for iron?
Fe.
Fe. All right. And do you know what that 3 tells us?
The charge.
The charge. Perfect. What is chlorine or chloride?
Cl.
Perfect. And what's the charge on chlorine?
2? Or is it
so
1?
Close. It's just going to be 1 because chlorine, can you see that? Chlorine is right, where is it? Right here. So it's in the 7th column or the 17th column, so it only needs 1 to get to 18.
Okay.
So it's going to have that -1. All right. And then magnesium metal, if we have magnesium metal, it's just going to be Mg by itself. Okay?
Okay.
So now we need to come up with our molecular equation, which is just our balanced equation that we've been doing since last semester. So our 2 compounds that we're going to, or element or compound we're going to have here, you tell me what the compound is going to be?
FeCl 3.
Perfect. And then we do have to use our solubility table because we have to determine if things are aqueous or solid, liquid, or gas. I'm just going to tell you because our solubility table is on a different chart, and I don't want to have to flip back through 18 different things. But this one's going to be aqueous plus magnesium metal, which is just Mg. And do we think magnesium metal is going to be aqueous, solid, liquid, or gas?
Solid.
Perfect. Okay, so we have our solid. And then what kind of reaction do we have here? Do you remember? We have a compound and an element.
Single replacement.
Perfect. So we're going to have a single replacement reaction. And can you figure out what our 2 products are going to be?
MgCl and Fe.
All right, we're super close, okay? But one thing I want you to remember is that we have to look at our charges for Mg. So what's the charge on magnesium? Do you remember?
2.
+2. And we know that chlorine has that -1 charge, which means Mg.
Cl2.
There we go. All right. And then I'm going to tell you that this one is, again, aqueous. And this one's going to be our solid. Okay. And now we have to balance our equation.
Okay. Fe's are fine. Double. So that would be 6. Put a 3 there. Put a 2. So then. Yeah. Do you want me to say what the balance is?
Yep. Tell me your balance equation.
2 FeCl 3.
Okay.
3 Mg.
Perfect.
3 MgCl.
Sweet.
And 2 Fe.
Awesome. All right. So now that we have our molecular equation, so that's our balanced equation. Those are the exact same thing. Now we have to come up with a complete ionic equation, which means that we have to do something that's a little bit different than what we've been doing previously. because aqueous solution means that we have a container full of water, and then this got dissolved in water, so we have Fe's with their charges floating around, so Fe plus 2, and we have chlorines with their charge floating around in the liquid. They're not together anymore, but they're floating around in that water, just like separated. So what a complete ionic equation wants us to do is it wants us to separate those aqueous solutions. It wants us to break those apart and write them as just the ions. So we're going to write out all of our aqueous solutions. So anything that says AQ, so that one and that one for this one, we're going to write them out as their ions separate in this equation. So if we look at FeCl3, we're going to take Fe and we're going to break it apart from the Cl. So we're going to rewrite Fe with its charge, Fe plus 3. And how many irons did I have in that compound?
With the balance or without the balance?
With the balance.
2.
2. So we're going to put a 2 in front because we still have to have a balanced number of ions all throughout the entire the equation, even though now they're separate. So we write our Fe with our plus 3, still an aqueous solution. Now our next step is to look at our chlorines. So our chlorines, we know that our charge was a -1 because you told me that earlier. How many chlorine ions did I have in that compound with the balance?
6.
You had 6. Perfect. So we're going to have those separated. If it's a solid, a liquid, or a gas, it's going to stay a solid, liquid, or gas. We're not going to touch it. It's just going to come straight. Oh, it's just going to come straight down into our complete ionic equation. So we're just going to keep the 3 Mg solid. And that's our reactant side. Now we're going to do the same thing with our product side. So we're going to draw our arrow. And we're going to break apart our magnesium chloride because it's aqueous. So how many magnesiums do I have?
3.
I have 3. And we said the charge on magnesium was a +2. And it was aqueous. And then we add to that, we have how many chlorines?
6.
6 chlorines with that -1 charge. And these were aqueous. And then remember that because our iron is a solid, it just comes right into here. And we just leave that solid into this problem, so we don't touch that one. So now we have our complete ionic equation. It gets a little bit longer because we broke everything apart, but we have one more step. Are you good with this step?
Yeah.
Awesome. So our last step, I'm just going to change colors again. All right, our last step is to go through our complete ionic equation and get rid of anything that's on both sides of our yield sign. So on the reactants and the product side. So if we take a look, is iron, do we have 2 iron ions in aqueous solution on both sides? You see 2 Fe's with a +3 charge on both sides.
Yes.
Where do you see the other one?
Oh, that one doesn't have the +3 charge.
That one doesn't have the +3 charge.
So no.
So no. So we're going to take that one and we're just going to bring it down into our net ionic equation. We're going to put our 2 Fe with the +3 charge as an aqueous solution. Bring that back down. Now our next one, the 6 chlorines. Do you see 6 chlorine ions on both sides?
Yes.
Yes. So we're going to take those 6 chlorine ions on both sides and we're going to cancel them out. They're going away. Just like in math class, if you have the same number on both sides, it can go away. We're going to do the same thing.
Okay.
All right. Now, our next one, 3 magnesium solids on both sides. We see 3 magnesiums on both sides as solid.
No.
No, so those are going to come down into our net ion equation. We're going to add the 3 magnesiums as a solid. And we're done with our reactant side. So now we draw our arrow, our yield sign, and everything that we see left on our complete ionic equation has to go in our net ionic equation because nothing else can cancel out with it. So we're going to bring down our 3 magnesiums with the +2 charge as aqueous. And we're going to bring down the 2 iron solids. So our net ionic equation just shows us how to make our solids. Those other ones, the chlorines in this case, because there's only one that canceled out, those are going to be called spectator ions, and that's on the other worksheet from yesterday, but I'll write it here. They're spectator ions, and those are ions that don't get involved during the reaction. So they're the things that just don't react, and they're just there because they're part of the compound. They're not reacting with the equation.
Okay.
You want to try it again, or?
Sure.
All right. So we have barium bromide. So do you know what barium's element symbol is?
Ba.
Ba. Do you know the charge of barium? This up again here.
2.
Perfect.
Wow.
Bromide. Do you know what that element symbol is?
Br.
Br. And do you remember the charge on that one?
I think it's -1.
Perfect. All right, we're just going to do sodium as well. So sodium is what element symbol?
Na.
Perfect. What's the charge?
2.
It's close. That one's right here in that
1.
first column. So it's going to be a 1. And then sulfate's actually on the back of the periodic table. And that one is going to be way up here. If you can see, it's going to be that SO4. And then if you see, it has that -2 charge. So now our reactants. Can you tell me the compounds we have as our reactants?
BaBr2.
Perfect.
Plus Na2SO4.
Awesome. All right. Now I'm going to tell you real quick that these are actually going to be both are going to be solids, or sorry, not solids. They're both going to be aqueous solutions. Okay.
Okay.
Just because I don't have the solubility chart in front of me. All right. And aqueous. All right. And now let's come up with our 2 reactants. So can you tell me the 2 reactants now?
BaSO4 2.
So careful, because look at the charges of Ba, so it has a +2 charge, and SO4 has that -2 charge. So what happens if they both have the same charge?
Cancel out.
They cancel out. So it's just going to be BaSO4. And what's the other one going to be?
BRNA.
B. Perfect, but we're actually going to flip those because we're always going to put our metal first. So it's going to be plus NaBr. And I'm just going to tell you real quick, just because you don't have that solubility chart in front of us, the BaSO4 is going to be a solid, and this one's going to be aqueous, all right?
Okay.
So now I want you to balance this equation.
All right. Looks like it's just yeah. 2 on NaBr.
Perfect. All right. So now we have our balanced equation. We're going to do the same thing. We're going to come up with our complete ionic equations. Do you think you can start that for me?
Ba +2.
Perfect.
And then Br -1.
Okay. Do we need to add anything else to either of those?
No.
So careful, one thing to remember is that this 2 down here, we need to tell me that now that we have 2 sets of those. So we got to put a 2 in front of our BR.
Okay.
Okay. So now let's do the next one.
Two Na +1.
Awesome.
SO4 -2.
Perfect.
Ba.
So careful on this one. See how the whole thing is a solid?
Yeah.
So we're going to keep this whole thing together. So we're just going to rewrite that one right here as a solid.
Okay.
Okay.
Two Na +1.
Awesome.
And then Br -1.
All right, we're super close on this one again. So if we look, that 2, don't forget that 2 distributes into the Na, but it also goes to the Br. So we have to put a 2 in front of our Br as well.
Okay.
All right. And now we need to come up with our net ionic equation. Let's use this one. All right. So Ba +2 charge in aqueous. Do we have that on both sides of our equation?
No.
No, so we're going to bring that into our net ionic equation. All right. What about the 2 bromine ions in aqueous solution?
Yes.
Yes, so we're going to take those 2 bromine ions and we're going to cancel them out on both sides. They're gone. They're spectator ions. What about our 2 sodium ions in aqueous solution?
Yes.
Yep, those are spectator ions too, so they go away. And what about our sulfate ion?
No.
No, so that one's also going to come out down into our net ionic equation. SO4 with a -2 charge in aqueous solution. Because that was our last reactant. We put everything else from the product side that hasn't been canceled out. We put that in our products, which just leaves us with the barium sulfate as a solid. Oh, not aqueous. There we go. All right, and as you can see now, we have just our barium ion plus our sulfate ion is going to make our barium sulfate as a solid. So it sets up to make just whatever's needed to create our solid. Not too bad, right?
No.
All right. So what I'm going to tell you to do is maybe just try two more for sure. And then if you want to keep going, you have, I think there's 8 problems on this sheet. Or 9 problems on this sheet. So you have 9 problems that you have the opportunity to do. I think I'm only going to require you to do 2 more problems because then it won't take you as long to get through them. So if you want to practice with the 2 more problems and then just be done, or if you want to do all 9 problems before you finish, whatever you want to do, all right?
Okay.
All right. Do you have any other questions about anything we've done so far? Or?
No.
All right. So the one thing I do want to tell you, because I'll post this on the Canvas later, but we are going to have a formative next Monday on both the net ionic equations and the vocabulary. So you're going to have like a multiple choice quiz for your vocabulary, and then you'll have a net ionic equation problem to do for a formative on Monday.
Okay.
All right. All right, Alex. Thank you for stopping in today. I'll see you hopefully next week.
Yep.
All right.